Question number 28. This example will require you to remember conservation of energy and conservation of momentum. For conservation of energy, you remember that we have elastic potential energy if we are dealing with the spring, and you can see that they are giving us K, which is spring constant, and they're also telling us that in the beginning, that particular spring with the K of 280 newtons per meter is compressed the distance of 9.8 centimeters. You'll remember we'll have to convert that to meters. So we have initial elastic energy, which will then, once these two objects are allowed to move, will convert into kinetic energy 1 and kinetic energy 2. Since there is frictionless surface, we will lose no energy, and all elastic energy will turn into kinetic. Kx squared over 2 should be equal to m1 v1 squared over 2 plus m2 v2 squared over 2. All those 2's can go away, so kx squared equals m1 v1 squared plus m2 v2 squared. I know k and x. I do not know v1 or v2. It's impossible to solve an equation with two variables. It is possible to solve a system of equations. So what else do we understand? We know that in the beginning, the total momentum of the system was 0 because everything was at rest. Since the only force that is at work there is the force of the spring, and it's the internal force, it's like M2 is pushing M1 to the left as strongly as M1 is pushing M2 to the right. That is considered an internal force. There's no friction, no air resistance, no nothing. I can say that this is a closed system, and the total momentum is conserved. Total final momentum is still 0. If total final momentum is still 0, then I would say m1 v1 should be equal to negative m2 v2. We are looking for find the final velocity of each object, so it doesn't really matter which one we'll go for. I'll go for v1. So v1 will be m2 over m1 times v2. Then I'm going to go back to this equation, and kx squared will be equal to m1 times m2 m1 squared times v2 squared plus m2 v2 squared. This m1 and this m1 will go away, squared. Kx squared will be equal to m2 squared over m1 v2 squared plus m2 v2 squared. So from there, v2 is going to be a root of kx squared divided by m2 times m2 over m1 plus 1. Using the numbers, so root of 280 times 0.098 squared divided by m2 is 0.88, 0.88 over 56 plus 1. So this is like 11 over 7 plus 1, 18 over 7 times 0.88. That will be 226, and then we do root of 1.1 meters per second. That was the heavier object. So this right here is 1.1 meters per second. So then obviously the smaller object will be moving a little faster, and conservation of momentum, I will just take care of the absolute values. m1 v1 will be equal to m2 v2, so 0.88 times 1.1 over 0.56 gets me 1.7 meters per second. So this will be 1.7 meters per second to the left, and that is 1.1 meters per second to the right. That's it.